So my name is Anastasia Kazakova. So I work for the company called JetBrains. I'm actually a C++ developer in the past. I was doing embedded development in the network in various gateways and routers for 8 years. Then I moved to JetBrains, where I work as a product marketing manager and do some evangelism around our tools. But today I'm not going to focus on our tools. I'm going to focus on the whole C++ ecosystem and talk about code quality and which tools we have and which tools we miss and maybe why. I will be mentioning our tools, but if you would like to learn more details, come to our booth. That's a better place. Not here, sorry. Yeah, and I also heard that there was some very similar talk yesterday. I unfortunately arrived just today, so I missed it. Hope that those who were at this talk yesterday will learn something new, or we will have some topic to discuss today. Just come to me after the talk, or just raise a question. And another disclaimer is that I definitely can't cover all the tools into 1 hour slot, so I will try to cover those that I feel are important and to cover the general trends. And I hope so that will be enough. So if you know the tool that I'm not covering here, that's possible. And that's definitely possible, but things happen. So now let's start. I will start with a very famous quote from Björn. And I think that many of you have heard it, that C makes it easy to shoot yourself in the foot, C++ make it harder, but when you do it, it blows your whole leg off. And there is a nice page on Bjarne's site that calls, in the URL, it has really say that, just to confirm that he really did that, and that's the first quote on this page. And there is an explanation, actually, from Bjarne, which is more important, and he tells there that he actually thinks in that way about all powerful languages, because powerful languages they brings solutions for harder problems, and when you protect it from simple dangers, you get into harder problems since you don't suspect them, and the powerful tool brings you into the situations where you're just blowing your whole leg. But I believe that the C++ is tough in some sense, and it brings some specific problems that are not possible for our languages. And if try to summarize all the general problems that we might face with the C++, so I think that the first point is that we still have the C heritage. So we still have C and C++. And many people in C++ development, they do C but pretend they do C++. They do C++ but pretend they still do in C. They mix in them. They are asking dozens of questions on Stack Overflow on what are the C features that are not available in C++? What are the C++ features that are not compatible with C? I saw dozens of threads like that, the discussions around designated initializers or compound literals or whatever. So the people are discussing it still. There are discussions lasting for a very long time. And there is also a big part of a legacy code available and the modern code, and very often they coexist. Very often you take a very old library and you try to build a project where you're using this old library, and all these styles, all these problems, they are just in one project. And also there is new standards, and there are new standards and old standards. There are upcoming standards with technical specification. I quite often hear from our users, for example, that, hey, I would like this feature, I'm using it in production for 2 months, but stop, it's in the technical specification. It's not even standardized, but you're already using it. And you're doing it in the project that has some legacy library. And that's quite a crucial mix-up, quite weird sometimes. There is a nice thing appearing in that sense, upsell libraries that were announced by Google at CPP Con in September, a very interesting approach how to move to the new language features when they implement something very similar to how the new feature is working, and helping you to move to this new feature step by step. But still, this mix-up exists. And also, with more functional and mathematical concepts come into the language, come to the modern C++, the C++ became not only the language that is hard for those who are starting the language, but for those who know the language for 40 years old already, like, because they know the language that was existing like 10 years before, and the language now is completely different. So they become the newbies with every new standard. And that's actually difficult, so that's not an easy thing. And we are missing a lot of tools. So we have a lot of them, and we still miss a lot of them. And that's actually quite an interesting situation, because you might say, like, everything faced this experience, but that's not true. I was doing some marketing, some evangelism around iOS tools and some Apple ecosystem, and the situation there is completely different. So they have code styles, they have standards, they have tools provided by Apple, and that's the standard. They have some additional tools provided by someone else, but usually they are either becoming a standard approved by Apple, or they just move to nowhere. Very rare tools actually exist in this ecosystem not belonging to Apple and not approved by Apple. That's a very rare situation. I'm not saying it's good or it's bad, but it's different. Talking about the code quality, I would like to tell a story. And the story is about the bus test. That's a very popular task in IT companies, when you check if losing one person from a team adds any harm to your project. And I could say that I work in the company where we completely failed with the bus test. We were doing a system completely written in C++ and some C and some Lua for configuration. It was doing some software for 4G and LTE networks in Russia. And each time the core developer was leaving the team, we were completely rewriting his part of code from scratch, his or her. And that was that's not a normal situation. That shouldn't happen. But because we understand that it's much easier and cheaper for us, it was to rewrite the code than to support, maintain, and evolve it. And that what I guess was a bad code. That's a bad quality. Another story is actually about a very famous thing, and it's called Goto fail. And if you haven't heard of it, so that's a very story about Apple, which once published an update to the iOS, which said this very nice line, an impact was that an attacker with a privileged network position may capture or modify data in sessions protected by SSL. Wow, that's huge. Someone could get my data from SSL. That's really a huge break. And that happened, so luckily that was an update published, and when the people start searching, since the SSL code was open source, they found, in the history, they found the code like that. It just had a doubled Goto fail line. Just everything after this Goto fail became an unreachable code. And someone just missed that. And there were huge discussions about, some people blamed old-style Goto statement and the whole architecture. Some people said that the error handling idiom should be different. That's all true, and you can catch actually this error by many ways. So you can format, indent properly. You can run the code analysis. Actually, the unreachable code here could be caught by the Clang compiler, but if you have the warning turned on, but who turns on the warning in compilers? You could do testing, you can do code review, you can do many things, but still the story is that the error happened, it was fixed, but we now have some kind of a good story about what could happen. But that's just a plain C code. Let's come more to C++. We got used that the C++ always has the visible types, the types that are obvious that we can just get by reading the code. But it's not true anymore. If you take this code, the types here, the type for the operation result, it just deduced from the actual usage of the operation function. So I don't have any single type written in here in this piece of code, but actually we can deduce that the operation result is table. And that's an interesting thing. That means that the readability of the code, it becomes like, it's very important, and it's harder to read the code and to understand it from the first glance when you get some things like that in the language. Another example here is somehow connected to all the heritage we have in C++ for years, and it's about macros and textual substitutions and all this how we have coming from the back years. And in this piece of code, it's very simple. It has just some if-def magic, and under this magic, we are defining x, which is either a type or an integer. And that means that in the very last line of this test function, this is either a cast or an expression. And you have to understand that from knowing what is x. Is it a type or not? So we need this information to understand what is actually written in this line. And that's tricky. And some could say that the good readable code should avoid writing some examples like that. That's maybe true, but that's possible. That's what we can do with the language. Since we've decided to talk about the code quality, let's first try and somehow define what the code quality is. So there are several definitions for the code quality existing in the programming world in the whole. So some says that the code quality is just easy to read, maintain, use, and correct. The code should work correct. There is also this kind of consortium for IT software quality that once issued this definition consisting of 5 important words. So reliability means the likelihood of potential application failures. Efficiency is in terms of performance or people resources or whatever efficiency you actually care about. Security is just about some kind of a likelihood of potential security breaches like this Goto fail error. Maintainability is a very important thing here because it's the characteristic of how easy you can adapt and port your code, for example, to another platform. How easily you could transfer, how easily you could enlarge the functionality, like maintain your code. That's what we actually failed with my example with the bus test. And the size is actually the quality of reducing the copy-paste effect or removing some long functions from the code and increasing the readability and removing the redundant code. These are good definitions, but I personally like this definition much more because that's the real life. This is the only valid measurement of the code quality. And the picture presents the code review process. But it could be like anything here. It could be maintaining the kind of application you are doing, kind of supporting the application you are doing, like reviewing the code or adding some new functionality. This is the only good measurement. Okay, so once we define some kind of code quality, whichever definition you prefer, let's come to the tools. So Björn said many times during the past 2 years that tools are important. Other people from the community and C++ committee saying from the stages that the tools are important and we need tools. So why the tools are important? Like when the Björn, for example, was talking about the C++ core guidelines in 2015, that was the major point. We need tools. Why so? That's actually quite easy, because if no one is throwing the exact rule into your face while you're writing the code, no one will follow this rule. You may remember about the good rule of how to write a good code for half an hour when you started implementing something. But then the deadlines that happened yesterday came into your room. The managers come in and say, we need a new functionality. The team members go into some other company and you get some new team members that you have to teach and they have to support the code. Whatever is happening with your team, you start forgetting about the good rules. If the tools are not forcing you to follow the rules, you will forget about these good rules whenever you can. I believe there are people who are always remember about the good rules, but do we always, all of us, do that? I personally don't. I will forget about the good rules when I'm in a critical and stress situation, and I believe many of us do. So the tools are here exactly for solving this problem for us, constantly throwing the good rules into our faces and forcing us to follow them. So talking about the code quality, I used to separate 5 groups of the tools here. So the formatting tools, the tools for the code style, tools for the code generation, code analysis, refactoring, and unit testing. And I'll now go through this list step by step, and we'll talk about the exact tools in this list. So let's start from the formatting and code style. So formatting is about like how the code is indented, so what are the spaces, what are the break-ins, what are the line breaks, how the code is generated, so how it looks like, and it's also about some style things like naming convention and many others. If we talk about the C++, C++ is actually having a very nice specific if we talk just about the formatting. Let's take this example. We have the last 2 lines in the test function. They actually look very similar, like the line with A and the line with B. They look like they're just the same, but they are not. Because one is a C-style cast and one is an expression. And in case you have different formatting rules for these situations, the tool have to format them differently to make the difference for you. And it's actually good to make this kind of difference so that you can visually distinguish one situation from another situation. But what it means to the tool, that means that the tool that is doing the actual formatting should know this information to format them differently. And this information is exactly what I was talking before, to understand if something is a type or not, which is a crucial thing for C++. But what does it mean to understand about the type? That means that the tool that is doing the simple formatting, just placing the correct spaces in your code, should parse and resolve your code, should understand the semantic behind your code. So the syntax is not enough. So the first problem for the formatter is that it should actually parse or resolve, at least to some extent, the C++ code to format it properly. There are a few other points here happening for C++ formatters. First of all, we have the variety of formatting standards. There's lots of quite popular style guides, like from Google or from LDB, LLVM, Qt, GNU, Chromium, whatever, WebKit. So we have lots of them. Like in many other languages, there is just one standard de facto that everyone is following. That's quite simple. We have many of them. And some companies are even having their own style guides that is not convertible to, like, it's not some popular style guide, it's just their own one. And the problem is that these style guides sometimes are different in essence. That means that you can't simply convert one into another because they are talking about different things. One is talking about spaces, one is talking about naming conversion, one is talking about some other things. So they are not covering the same set of settings. So converting this kind of style guides one into another could be a problem for a tool. Okay, so another question that is actually happening for the formatting is when to reformat. But that's actually have a very simple answer. That's actually several answers here. So you can reformat on the file save. You can reformat on the fly, which means while you type in, the tool is formatting the code for you. You can have a pre-commit hook, and that's, I get, the way for most of us to use the clang format tool. And there could be some like explicit actions that you can call and say like, okay, reformat me this piece of code. So actually this kind of a requirement when to reformat defines the tool quite a lot. So for example, the IDEs, they mostly select the on-the-fly formatting because they have a lot of information about parsing your code. They try to highlight it properly and try to reformat it properly on the fly. The pre-commit hook is, as I said, mostly used by people when they're using the clang format, just setting it as a pre-commit hook. But if we're talking about the clang format, so there is many ways to use it, and there is a very nice Vim integration that suggests you the clang format could be used on the with a special shortcut or on a save, so just placed as a save hook. And what I like about the Vim integration is that you can actually select the piece of code, and the Clunk format integration will just select the next bigger synthetic correct entry and reformat it. So it just not breaking anything if I just forget to select a couple of symbols. There is some very similar integration for Emacs and other tools. What I like about the Clunk format is that, first of all, you can turn and off any piece of code from formatting. You can just write this command like Clunk format on off. That's just a usual command, and the Clunk format will skip the formatting of this section. The second good thing is the library profiles. That means that quite often you have one formatting for a library because it's coming from the library author, and another for your particular code that you're writing. And it's good to format them differently. And the Clunk format actually allows that, so you can put different profiles into different folders, and it will use these profiles while reformatting. But there is always one thing that is going wrong, as usual. And the problem with the Clunk format is that while still it's the part of LLVM ecosystem, but it's using a fuzzy parser. That's reasonable because that allows the Clunk format to be very quick and just reformat like on a speed of light. But on the other hand, it could fail, and it actually not just a fuzzy parser. The problem is that it doesn't look into header files, and so it could parse incorrectly if it was messed up with this kind of information. So, but many people use the Clunk format and they live with that and they okay with that. But still, you have to take this on mind and to remember about that. So if we talk about the IDE's formatting tools, which I would like just to mention quickly here, is, as I said, usually the IDEs, they have the built-in formatter tool that is just working on the fly while you're typing. Some of them, for now, are integrating the Clunk format. But the biggest issue, usually for the IDEs, is how to import and how to convert different styles, because when you implement something, then the people are coming, for example, with the Clunk format code style, and you have to think about how to convert it to your settings. That's actually the thing that the NetBeans is currently doing, so they're their integration for the Clunk format, just converting the settings from the Clunk format into their own settings, and that's the same that the ReSharper from ReSharper for C++ team is doing. At JetBrains, they are also just converting the settings from the Clunk format into their own formatter. Another thing that I'm going to mention here, talking about the formatter, is that actually the tool that we implemented, it's not the fully functional tool. That was a project at our hackathon in 2015, I guess, and we call it extract style project. So it was using some kind of a genetic algorithm in order to extract the style from the code formatted properly with some style. So it just had a big set of settings, and it was running some genetic algorithm with genome as a list of settings and the fitness function as their modified function of lexical distance between the texts. And so there were some optimizations implemented, and finally the team who was behind this hackathon project managed to get some tool that we actually used in the real production tool in CLion to extract Google and GNU styles from the actual code. So this extract style project is not in any way some kind of a public project that we are suggesting to someone. That's just our internal thing, but I hope we could later put it to some tool just because it's a very nice thing. And by the way, there was a very interesting story while we were doing this kind of extracting. And this is a story about how the formatting could be different, because there is this kind of Björn Stroustrup code style that is described on his site, and he has actually lots of code that, as he said, should be formatted with the style, but when we were extracting the actual style, we found a lot of conflicts in this piece of code. And so we just failed to extract this Stroustrup code style from these code pieces, so extracted only two. Okay, that was about the code formatter. Now about the code generation, which is very important. Why? Because this is a good way to keep to style guidelines and to use some common design patterns that are like popular in that you have to use in your project, in your company, or some just general good patterns. And that's a good way to avoid errors and various copy-paste errors and other things. So, and there are many things that could be actually auto-generated. So starting from the typical file templates, when you can just add some guards, or you could add some commands about who is actually implementing this, this file. And there you can also generate some comments, for example, doxygen stubs, like to document your functions. So if you have a function signature, why not to generate a doxygen stub that you can later fill and get a documentation for your functions or classes. And there is, of course, some generation for various code snippets, like you can generate how the class could look, or getters and setters, or constructors, or whatever. So currently, in the modern world, IDEs are capable of many code generation features. So they can generate many things, like from these basic class templates and getter setters and whatever. So like namespace definitions, or try-catch blocks, or using, and some kind of like operators, like we generate in CLion and resharper C++ and resharper C++, that's capable of generating even some great stuff like swap and hash functions and some other things. So I would like just, so you see this is a big piece of code actually, and I will show it to you how I actually generated all of it. So that's not the handwritten code. All I have written in hand was just the private members for this distance class. And all the rest is going to be completely auto-generated by the tool. So I'm not going to write a single line in this code. So the tool could provide you some like options, like to use std for the operators, for example, like why not, or to generate in place, or whatever you can create here. Yeah, so that's like stream operator that is generated here. Yeah, so that's it. So you see there is a big, like, there was a huge list of lines, so I will come back to this slide, and like all of it, except for the first lines, were just auto-generated. Like, except for this kind of a built-in code generation into various IDEs, there is also some specialized tools like Readable or Clonk that is still used for some transformation. And some actually Clunk-based tools is an interesting approach here, and I'm waiting for more here because Clunk is aware of an actual AST, and that means it could generate a lot, because if you have an AST, you can just generate many things based on it. But surprisingly, there are not that many projects like that around the web. But what is much more interesting here is actually the Matic classes. So, like, Herb Sutter is talking about the Matic classes as a like good way to make C++ like smarter but simpler, and I think that's a good way to do the code generation, because you are doing the code generation on the compile time while you're compiling the code, and you can just avoid all this kind of a boilerplate code and follow some exact conversions that you are just putting into the Matic class, and that just then it's just generated automatically by the compiler for you. So, and this is just the example from the Herb's proposal with this interface shape and the Matic classes there, and then here in the bottom you have the actual code that is coming out of the compiler. So the idea is here that you're just avoiding hours of code generation by simply implementing all you need in one Matic class, and then just the compiler generates everything for you automatically. So that's just some kind of a next step to the code generation from my point of view. And yeah, actually the good thing is that you can play with it in the like compiler explorer. I know like Matt Godbolt is mentioned many times at this conference, and I will continue doing this. That's a good trend. So you could try this on Matt's compiler explorer and play with these Matic classes. It's very nice exercise to play with the code generation. But what we really need is a tool support for that. And that will be a very crucial thing to have when the Matic Classes arrive. And I hope the tools should be prepared, because what is actually important here is that because you don't see the actual code generated before you actually compile all you have, so you see just the code that you've written, like one on top, and you have this Matic class definition, so not just to generate everything in your mind, just to understand what's going on, what's going to have to happen in the very end. The tool should probably provide you some preview of what's going to happen in the end before you even compile, and that would be great. But that means that the tools have to do some kind of interpretation for the whole Matic Classes story and show you some result. But that would be a very bright future, actually. Okay, coming from the bright future to other reality. So code analysis. Code analysis actually could be divided into two parts: static code analysis tools and dynamic code analysis tools. If we start with the static analysis, so this part is also could be divided into two parts. So compiler errors and warnings, which are very important, but you always have to remember about them and turn them on. And some extra checks that could be done that are not caught by the compiler, like dataflow analysis or some style things, whatever. And here we have plenty of tools in the C++ ecosystem. And some of them are quite old, some of them are quite new. Let's see what we have. So one which is very, very popular just because it exists for 10 years already is the CPP Check. It started in 2017, believe me or not, so it's 10 years old for the tool. They have approximately a little bit less than 200 of checks, and it's used widely on the project. That's for example, in CLion, I guess that was one of the first plugin for some analysis for the tool implemented by just our users. They just implemented the plugin for CPP Check because they thought it's important, because many people are actually using it nowadays. And there are plugins for Eclipse, there are plugins for Visual Studio, there's plugin for Qt Creator, and it's actually doing a basic set of checks, not very capable of modern C++ features, but still very important, like all this out-of-bounds story or checking the variable scope or some size-off arguments, whatever. But as I said, it's not really capable of the modern language, and it's actually not very good with the modern language. So there is also a Clunk Analyzer, and that's a great tool because once you have Clunk, you have this kind of analysis, because it's just built into the Clunk. So you just ask Clunk to analyze the code and to show you the actual results, and you are done. And so that means that you can get it in there is many tools that can show you these results, and it's actually not only for C++, it's checking C, C++, and Objective-C. And there is also a clang-tidy now, which you can run with the option Clunk Analyzer and get all the warnings from the Clunk Analyzer standalone thing. And there are good checks, but not that many of them, actually, just around 40. But there are some core checks with the visibility and scope. There are checks for new delete pairs. There are checks for some dead code and some other thing, like some division by zero, null dereference, and others. Which is more is the clang-tidy, which I already mentioned, so which from one point of view, it includes the Clunk Analyzer. From another, it has much more. So it's more than 200 checks for now, and it includes a very important group that is called Modernize. And I would like to specifically point it out here, because Modernize actually help you to transform your old code base to the modern C++ standards. And that's very important, because someone actually, or some tool should help us with that. Otherwise, we'll be dealing with the legacy code for a very long time. And actually, clang-tidy Modernize can do that. I will run another demo. So the demos that I'm showing is the integration into CLion, but there are other tools that could do this kind of integration and running clang-tidy. So that's just the clang-tidy running, and just the fixes are applied. That's the fixes that the clang-tidy provides. So you could get the same result if you just run the clang-tidy minus fix, and you get the same substitutions. So you see it could change the ask to debind thing, these kind of for loops, and other stuff. Okay, clang-tidy is good. Let's move to some other good point here, is the C++ core guidelines. You couldn't talk about code analysis nowadays without mentioning the C++ core guidelines initiative. It's not the tool, it's the set of rules. It's the great list of good guidelines and how the things should be. But if we see, on the actual tools that are supporting the guidelines, there is a support in clang-tidy, but it's not that many checks that are supported. It's around 16. But since the clang-tidy is open source, everyone could contribute, and so we hope that the community could contribute more. And other tools are either supporting the core guidelines through the clang-tidy, like Eclipse, CLion, or NetBeans, so just running the clang-tidy, or some native support for C++ core guidelines that's implemented in the Visual Studio. And there is some nice demo from cvelop tool from Peter Zormerland, who also shows how they implemented some of the C++ core guidelines checks. Talking about the code analysis, I'd like to mention the Coverity here. It's the tool that's mostly used by some big companies, and it's quite understandable because it has a very nice business process integration. So it has some plugins for continuous integration support. So how it's usually used, so while it has not that many checks, so just around 80, it's still the tool that you can run on some servers. So on a server, you just run in the tool on your code base, and the developers are just getting some reports from the Coverity, trying to analyze what actually went wrong in their code. That's the process that is built and is working in many companies. And this is actually good, because if you have the code analysis tool running on a CI infrastructure, that means that you are running code analysis constantly. There could be other ways to force you to run the code analysis constantly. For example, in CLion, we have this kind of tick run code analysis on commit, to check the code before the commit. Also, there is ways to run code analysis on code review stage, and and some tools trying to do something like that, and this kind of CI integration that Coverity provides. So this is actually just a good way to force everyone to run the code analysis tool. There is actually more. So there is a PVS Studio that is providing lots of checks, and there is info project from Facebook that's actually interesting because it's not just a code analyzer, but it's just a system built with the idea of formal verification of the software. And that's just some interesting project. And many other IDE checks, many IDEs just provide some their own engine that just runs the code analysis. And I guess most of the IDEs nowadays just do that. So, and talking about the dataflow analysis, because this is the analysis that is different from what you can get from the compiler, because compiler is never checking the dataflow analysis. But it could catch some interesting issues in your code, this is the data flow analysis implemented in CLion, and showing you some interesting things, in the first example, condition is always true when reached, just because it analyzes the previous if statement and see what's actually going on in there. Or the second example where it shows the unreachable code, just because in the previous switch case operator, we are not assigning the yellow color to the C variable. So this is the kind of things that the compiler is not catching because it's not analyzing how the data flows. But it's actually could be done, and that's a nice thing to catch. If we talk about the dynamic code analysis, so there are lots of tools, but I could divide them into 2 big groups. The representative for the one group is the Valgrind, and the representative for the other group is Google Sanitizers. Why these groups are different? Let's look at this table. So the major difference is that the Valgrind is running your, like you can just run your executable with the Valgrind, and that means that your executable will be run on some kind of a virtual machine. So you don't need to recompile your executable, you just take it and run on the Valgrind and get the result. And the sanitizers are quite the contrary, they require the recompilation with a special compiler flag. And that comes to the second point, that the sanitizers, they require the support for the compiler. And if we talk about the exact Google sanitizers, they are available in Clang from 3.2 and some from 3.1 version, and in GCC from 4.8. And in that sense, if we compare to the Valgrind family, actually any executable will fit, and nearly every compiler that compiles that executable will work, because you just run this executable that you get under the Valgrind. This comes with some other problems. That means that these applications running under Valgrind will have the biggest slowdown. For Valgrind family, it's about from 20 to 50 times, and for sanitizers, on the contrary, it's from 2 to 5. So it's 10 times difference. It's quite a lot. And that comes of the different reasons, like Valgrind is running one thread at a time, and sanitizers are running actually the threads at speed. And the list of supported platforms is different, and actually the list of the checks that are available is different. The Valgrind is quite often think about as a memory check, but it's not, it's much more. It has lots of other things. And sanitizers are quite young, I would say, so there is a very good address, like some memory sanitizers, some thread sanitizers, but some things are just still like not available in there. And yeah, and both groups do not support Windows at all, so sorry. There is like Docker memory and some other things for Windows, but actually I guess the Windows users are not very happy with this situation. So talking about the Valgrind, let's quickly see what it's capable of. So there is a memory check that could check like the usual things that the memory check actually should do, like read, writes, and freeze, like using of some initialized or derived from initialized values, and like some fishy size, like some for size of, or some overlapping source and destination pointers in these kind of functions like memory CPI, and some memory leaks. So, and it looks like something like that, but that's again the integration into CLion. So if you run in the command line, it provides you just the kind of a stack. This is just the stack here represented on the left. So this is just the stack that Valgrind provides. And so you could check what the leak was. So it was invalid write or whatever it was, so initialized condition, and just try to. It also shows you like the position in the code, so the location. So and in other integration, we're just taking this location and providing you the code example side by side with the stack, so you could analyze. There is also a project called Valkyrie that is a Qt-based UI for the memory check and other tools from the Valgrind family that just visualize the result. So there are just some other way to visualize the result. There is also integration in the Qt creator, very similar to what we actually have in CLion. And it also shows you the stack and some location in the code that you could check and see. And in Qt creator, you could filter by the leak type just to see, for example, only the invalid writes, for example, yeah, or some other type of errors. But as I said, Valgrind is much more. So it has the cache grind, that is the cache profiler. It's nice, while it still has some accuracy points because it's the simulation. It's running on the virtual machine, and that means that it's not taking into consideration any kind of external processes, kernel scheduling done by the operation system or whatever. But still, like, could be a nice overview to catch a problem. Valgrind is analyzing the call history in the program. There are some problems with the recursive calls because like the cost is measured in the number of CPU instructions, and so they just turn it off by default for recursive calls. But you can play with the settings. You can set the how deep you allow the call grid to go into the recursive call or to skip some particular calls and to get some results. And there is also a very nice visualizer tool called Kcache Crane that allows you to see the results in some like GUI-based application. And there is more still. There is Valgrind for threads, there is Massive for heap profiler, and some other projects that are included in the Valgrind family. If we're talking about the Google sanitizers, so there is the address sanitizer, that is the base one, I guess. So that is catching all these out of bounds problems, use after free, use after return, so whatever when we're going out of scope. So some double free, some memory leaks via the leak sanitizer. Just to compare, that's how that's the stack that the sanitizers are providing to you. That's just very similar actually to what you get with the Valgrind stack. Interesting thing that there is also a thread sanitizer that helps you to detect data race errors when two threads are accessing the same variable concurrently and one of the thread is doing a write. So the C++11 actually bans such situations as undefined behavior, and it's good to catch them with some kind of dynamic analysis tools. There is also a memory sanitizer to detect initialized memory reads, the tool that was lacking in the Google sanitizers ecosystem from the very beginning and was the main argument for using the Valgrind, but they have now the memory sanitizer that is quite nice. Still, it's I guess, no GCC support. There is also nice things like undefined behavior sanitizer, a very interesting one because like in C++, you can very easily get into the situation of the undefined behavior. And that's the way for a compiler to protect itself from various like situations that could be quite difficult to understand. And getting undefined behavior in a runtime is a pain because you never know what was actually happening there, and you are trying to reproduce the issues that the people are having on one machine on the other machine, and you get the different behavior, and that's all because of this kind of thing. And so getting something that could allow you to check this undefined behavior is a nice thing as well. There is also a dataflow sanitizer, but that's not a check. That's an API, which you can use to implement some checks, which is also nice. But this is more like a work in progress, not something ready to use, and supports only Linux 64-bit, I guess. There is also some coverage callbacks and some other things that are currently that you could find in the Google repository for the sanitizers and see what's actually under development. Let's move to the fourth point, that is refactoring. So refactoring is a very typical thing that we all want to use. And there is a basic set that is the rename, extract, and inline. And there is some more profound set that we also would like to have, like some change signature, like extract variables, or extract parameters, or extract constants, or some like pull and push members through the types hierarchy, or like modernize, which the clang-tidy provides. So, and currently there are some refactorings available in various IDEs. Mostly the IDEs are doing this kind of refactoring on top of their own language engine. That's the way the CLion, ReSharper, C++, Qt Creator, Eclipse, NetBeans is working. So even if they have the libclang integration, so they're not using it for the refactoring. The only IDE that is currently trying to use the Clang-based language engine is in Xcode 9. They started doing some refactoring on top of the Clang. And there is also a clang-tidy for this kind of modernized thing that I've showed you already. So the requirements to the refactoring tools are actually quite tricky because the biggest thing is that they have to cope with the tricky C++. So they have to provide you the reliable result. So you have to be sure that after refactoring, you still get a correct code. And that means that they have to understand the code very good. So they have to do all this kind of parsing and resolving stuff. And you also always want them to distinguish C from C++ and to apply the refactoring to the whole project scope, not just translation unit, which is a very typical case. And actually, the Clunk rename that I'm going to mention here is a nice tool, but it's renaming inside the translation unit still. And that's a problem because you want to have your refactoring working on the whole project. And there is also a nice thing about non-code usages, like when you refactor something, you update the comments, you update some resource files, you update some stream output operators. That's also good because you can come to the situation when they are not updated. Talking about the refactoring, so there is a very nice tool introduced by the guy called Richard Thompson. He actually implemented this kind of refactoring test suite. It's around 60 tests for C++ refactoring for different refactorings. And he checked CLion, clang-tidy, modernized, ReSharper C++, Visual Assist, and Visual Studio 2015 with these kind of tests. And he has plans for checking some modules. And on this repository, you can find not only the code samples he was checking on, but also the results. And what I like about this guy indeed is that he created the bug reports for everything not working properly in our tools. He did an amazing job, believe me. So he has all these links on this page, and that's really incredible, and we're really thankful to him. And it's also an interesting tool to check. There are a lot of interesting code samples that can confuse the refactoring and is actually doing that quite easily. And so that's just an interesting set of examples to investigate, to check, to overview. Let's come to the unit testing. Unit testing is an important thing because if you do, for example, some refactoring without doing a unit testing, you can never be sure that you haven't broken anything. That's why unit testing is important in this kind of getting the better code quality. In the beginning of 2017, we did a developer ecosystem survey, which covered our users and some other people who are not using our tools because we were trying to promote it widely. And we got some results. We collected around 9,000 replies, and 5,000 of them was not from our users. And we got some statistics for the unit testing frameworks used for C and C++. And so for C++, we got this kind of results. So the most popular is Google test, then come the Boost test, and the others got not that much. So the CPP unit is 11%, UTest 5%, and Catch 5%, and the others got just less. And so that means that the people are mostly seems using Google test and Boost. So they're some kind of similar. They have some differences. And what I like about Google test, you have to compile your project with the Google test. That's the official way from the Google how they advise to use the Google test. They not advise you to use the pre-built binary. And Boost test, you can use via the header-only way, or you can compile it with your project. Actually, the header-only way is not recommended for big, heavily templated project because the build time increases. And the cache, for example, is a nice thing because you could just include one header file and get the whole unit testing framework on board. That's a very easy way to start with the unit testing framework when you don't want to grab the whole repository, put it into your project, put it into your build system, and build. But still, the Google test is one of the most popular for now. And I have the bonus point here, which is, of course, the package managers. I couldn't avoid them because, we are talking a lot about them these days, and this is good. For C++, we, for many years, had many problems with the package managers. First of all, they didn't exist for many, many years. That's the first and the biggest problem. And it actually was caused by many reasons. And one of that, I guess, is the one definition rule. So if you compile two things with different flags and compiler versions, you may get a conflict with different definitions for the same class of function, which causes the runtime issues. So you have to be sure that the compilers and the compiler flags are the same that you are using, or to do this kind of a usual way as we all do for libraries. Download the sources, build them with my project, include this into my project build. And all three steps here are quite tricky because download the sources, you have to find them. Okay, that's easy, you found them. Now you have to build the sources. That's good if the library author provided you with the instruction, but if not, you're struggling for one evening for trying to build this kind of library on the platform where the author never built it at all. And then you have to include it into your project. And since we have lots of build systems existing in the C++ ecosystem, that's tricky because the author has one build system, you have another one. You can't easily plug in one into another, and you're just suffering from that for a whole day long. And I know that there is a good thing now that the library authors are doing is they are trying, even if the library was not built with the CMake, which is kind of a very popular build system for now for the C++ projects, they still try to provide a special file that you could include and use this library if you are building your project with a CMake. So that's still possible, and that's a very good way, and that's a very good libraries that do that. That's really great, even if they are not building with the CMake themselves. And yeah, so the variety of the build system also is a problem for package managers. And package managers, actually, there is lots of criteria how to divide them into groups. Like they could be language level, or they could be external. They could be build system agnostic, or they could be built into your actual build system. But with the variety of the build system, it's nearly impossible to cover them all. You have to select one. There is source-based, or there are pre-built binaries, or there is a combined way when they try to guess if you have the same flags and build from sources, if not, or use the pre-built binary. And there is some system and language specific. Coming quickly through the kind of examples, I was very surprised when I found this kind of a proposal from Blizzard that's actually putting the package manager onto the language level. I was actually very happy that the proposal died because I don't think that we need dependency manager in the language. It's too much for C++. We have lots of things on board. But that could be a solution, actually, when you have all these things into the language. And they even got some kind of an implementation for a clank, which started in the repository by the first link and then was continued by another person into the repository by the second link, which is a fork that moved forward. But still, it was it's not updating for, I guess, 1 year already. So there are many things that were implemented, but still much more that were not implemented. But that was just some kind of an example how you could build an actual dependency manager into the language. Other ways is like to use a build system dependency manager, like Hunter is CMake based completely. And there is some like Hunter Gate that is a Matic package with build instructions and URLs or the real packages, and you can control this. You can set different URLs there. It supports different platforms. It has support for quite a lot of popular libraries. At least the top like 10 or 20 libraries are in the list and support it, so that's good. And of course, there is Conan, which was here just before me, and the guys are doing incredible job. So they have an external build system agnostic package manager, which has actually predefined helpers for CMake. For those who are a fan of CMake, they support different platforms and they're some kind of different languages. And there is also a very nice thing called like Conan profile, which you can use to store different configurations and to use different configurations at a time. And like, if you're interested in something like that, I really encourage you to check Conan because I think that's the best tool that we have for now. So at least among all we have. And so we'll see, maybe we'll have more. The variety is always good. And that's actually it. So I have a couple of like links here to some talks I mentioned or to this test suite from C++. So if you want, you can just grab some links from there. And the developer ecosystem survey that I was talking about is at the last link. So you could check all the results for all the languages we've covered. And if you have questions, I can try to answer them.
So,
So, any questions? Or everyone is just ready for grabbing some food? Okay, so, like, yeah, there. Just if you remember some question tomorrow, you can find me at the JetBrains booth and ask. I'm here for today and tomorrow. Yeah?
I think I missed perf.
Yeah, it was there on some slides, but I decided not to cover it separately, so it was, where it was. Yeah, it was when this group were defined, there was some, yeah, so something like that was there. So there's this line for gprof, gperf tools, and some more that is there.
Oh, yeah.
So I just decided not to cover them. They're like similar to, like there are a lot of tools for dynamic analysis. They're mostly similar to one or another group, either to Valgrind group or the Sanitizer group. So the essence difference is usually you either have to recompile, which is the typical case, or the Valgrind case when you just run on this kind of virtual machine. Actually, Valgrind virtual machine is very interesting. If you never if you never looked at this kind of sources, I encourage you to look. The IR there is very beautiful. So just a beautiful IR to overview, just a good tool in that sense. Yeah, but like the tool you asked, it's in one group there. Okay. No more questions? Everyone is just ready for the food? Okay, so come later if you have more questions. I will try to answer them. Thank you.